Hi, welcome to my project. Okay, I just want to quickly start on task 0 just to mention this is basically a curation task. All the data cleaning and the extraction of the relevant fields for the rest of the task is actually done within the tasks themselves. Here, this is the same line that's in all the tasks basically. And here it's very easy for you just to change your collection and to change your database name. I'll run this and show you the results once it's done. So we've got task 1 here. Basically, all we do is we extract it. We find all the tweets first in the collection. We use an empty statement for that, and this is the actual fields that we extract from the tweets. Next, we just use those tweets and we pass them to get text and Word. Basically, the text just cleans it using these statements. One to remove the URLs, one to remove non-alphabetic symbols, and we lower it. For words, we do the same thing, except we tokenize it into a list, basically, and we remove the stop words. Here is commented out another way of doing alternate way. You can just uncomment it and comment these if you want to try using the other method. I found that this one gives better results. Next we have get keywords, which just does some POS tagging. We have topic, which we create dictionary corpus, we train it on the model, pass it to model, and then basically we return it. Sentiment, we actually give it the text and it does it. And the reason there's no keywords that named entity is because we use the keywords for it. So we pass it the keywords, and the keywords which are named entities are usually tagged, or they all start with N, but they're tagged with NN, NS, and so on. And so we find it that way. Next we just convert them all to CSV. I can give you an example of one, which is, for example, with keywords, where we just get the keyword, we get the tag, we separate by a comma, and then we input new lines. Basically, all of this gets done over here in a loop, so we call all of these different functions. And the first and only thing we do here is we just check to make sure that the words is more than 0. So some, for example, body fields may have just contained a couple emojis, so they'll have 0 words in them. I'll run this program, and essentially we'll input these to the database, and that is if it can run the function. If the word is 0, then we'll just insert the keys without anything in them. Just to show you this, if we reload it now, you can see that task 0 completed and task 1 wouldn't have completed on the whole database, but for the first few tweets we can see that it's gotten the keywords, name entities, and so on. And you can see it's all in CSV format. Next is task 2. So for task 2 we had to build the map by reducer function using the mrjob module. So what we did is, or what I did I should say, I've gotten the regex regular expression, and this is just used to find the words. So basically what we do here is we get the line, we find the words using that statement, we lower it, so just make sure that they're all normalized, they're all lowercase, and basically for each word that becomes a key, and the value is just 1, so for one word. Combiner and reducer have very similar functions as well, except a combiner happens locally whilst the reducer is the final output. So you can see it in the flowchart here that I've created. So combiner does basically the same thing as reducer, but it does specifically to the mapped function, whereas reducer does it to everything. And as you can see here, we could basically map everything at keys and values, and then if we just look at reducer, we get those values. For example, here's all line was here 2 times, so it becomes 2. Now, as we can see, a very similar thing happens for task 3. We have a preprocessor for both tasks, and task 4 actually. There's not too much to explain here because this basically works the exact same as task 1, in the sense that it goes through the database. This time we actually do have to use a find statement, only because for some of these they don't exist, so this is just to make sure they exist, and so it can find them all, no problems. Otherwise we just pass it the field, same as with the preprocessor here. We just get the body field, reclean it using the same method. And for task 3 here, the only difference really is it's for a given list of cities. So basically what we do is we find the words once again, and this time we actually just match them up to this list of cities. This can be changed to any list of cities to go and try and count them as well. So right now this is just all the list of all the cities in Australia. So we get, for example, Sydney, Melbourne. So what we do here is the same thing. Basically, once we find the word and it matches up to a city, we just do the same thing and we yield that word, or we yield the city as the key. We map it with a value of 1, and then we reduce, in the reducer we'll aggregate all of the values. Preprocessor here, processor is basically same thing. Get the tweets. For here, you could use any amount of filters you want. You can get the whole tweet. You can get anything. The only thing that's important is that this ID is included and the actual ID of the tweet is included, because we want to sort by the ID. I've only included these two because I just want to keep the file small. So basically, look at task 4. This one just uses JSON format, and as you can see in the folder, so what we do is the preprocessor will output a file called input tweets. What we then can do is we can run it. So we'll go cd pass it the file path. Then we can just run it with the command python task4.py, pass it the input file, which is input underscore tweets .json. The output file is output underscore tweets .json, and typo. That should run with no issues, and so it's probably just recreated the file here, but I can show you them loaded up into the database as well. So here would be the output tweets, which would just be the sorted version. Output tweets 2 is the same thing, but that's actually the output from our merge sort function, which uses merge sort. Basically it just splits it up until you get one object in the array, and then it remerges them up by comparing left and right. It happens very quickly, and actually more quickly than MapReduce, because it's an n log n function, which means that's the longest it could possibly take. And as MapReduce has a few extra steps and so on, and it's made for distributed computing, it's not very optimal in this setting. Lastly, we have task 5. So what we do is we actually get the CSV of the keywords, which was generated in task 1. So you must run task 1 first. And I can run this here, no problem, I think. It's still not finished. So what we do is we get task 1's words, we build a vectorizer, we fit it, and then that's going to give us a TDIDF matrix. Then just to get the top n, we just convert again to, we're using a dust data frame, and we just use the n largest, and we call a compute function, and that actually returned us the top n.